Hello everyone, my name is Bolesław Dawidowicz. I'm really glad you're here, and today I would like to present you the survival guide to modern authentication and authorization standards. And I'm really glad to see so many people want to hear about security, so that's great. Okay, and the clicker is not working. Oh, okay. So, now it's working. This is the high-level talk, so I have only under 50 minutes. I'll try to cover a lot of stuff and more, equip you with a knowledge to dive deeper and more explain you what you need to look for and what to Google. So you will not see like a protocol level flows explained here. Sorry to disappoint you if you were expecting this. And that's my plan. So I'll talk briefly about SAML2. Then I'll spend more time explaining the whole OAuth2 ecosystem. I'll talk about the passwordless stuff, so especially W3C WebAuthn and FIDO2. And then only last few minutes I will talk about Keycloak. So that's not a Keycloak talk, but I'm from Red Hat and I work on it, so I'll mention it in this context. That's my too long don't attend summary, and I'm courageous to give it before the talk, but this is what I will try to explain you. So if you're doing any new application and you need authentication layer, OpenID Connect should be your choice and will cover a majority of your needs. But you should not try to implement things on your own. There are existing libraries, tools, or standalone solutions to leverage. W3C Web Authentication Standard, oh, I missed the N at the end. It's really hot stuff. It provides a lot of good things. You should embrace it. And OAuth2 specification space is still evolving, so it's worth paying attention. And if you have any custom or special needs, usually you will be able to find things in like already RFC draft addressing it. Okay, so let's get back to the basics. Really quickly, I guess we all know authentication is a process where you prove who you are, in essence. So you verify that who someone is. And authorization is when you're making a decision, should a given person, should a given process or a service be able to perform given actions or get access to given resources. Now, let's take a quick journey. Back in the 90s, when the web was born, the typical security in every application looked kind of like this. And usually it was as ugly as this, as we remember. We all know username and password. We still use it, this kind of login process in a lot of websites. The first problem here is single sign-on, which we all know and take granted right now. So you don't want to repeat the same authentication process and again and again and again when you access different websites. But this is not really that hard stuff. Like, we are all smart engineers here. You could all probably propose different solutions to address it. What was slightly more harder if you try to do SSO between different organizations. And the tricky part here is you go outside of your own domain space. So very simple solutions like cookie may not work anymore. And what makes it even more tricky is that by doing SSO between different organizations, you don't want to give those different organizations access to your database, to user credentials to verify their identity. So this is the use case we all know, and we do this on a daily basis. And especially, you may be familiar with this, like if your company is using Google for company email or Slack for chat, then you authenticate within boundaries of your employer, and then Google and Slack will recognize you and will authorize you to access the services without accessing database which is in your company. And this use case is called federation. And that's essentially what SAML2 was invented to solve. SAML2 introduced this whole architecture which we know today. So you have applications which are called service providers. You have a place where you log in, and this is called identity provider. And, well, you have something which accesses those services. So back then it was pretty much only the browser, not much else. And you know, you have interactions between those, and you have a ticket or token flying around, which by the specification it's called SAML assertion. And you essentially, you know, identity provider is issuing SAML assertion, and then this is passed to service providers, and they look at it, and they know it's you, and you have certain entitlements to let you in. And SAML assertions are pretty ugly by today's standards. So it's an XML document with a whole schema. This is actually a fairly short one. There are longer ones. It's not really readable. And you know, the major sin of 2019, it's not YAML, right? Okay, so in summary, what you need to know about SAML, and it's a fairly old technology, why I'm bringing it up here. So this was finalized in 2005, but it's a very widely adopted specification. Every single major security product supports SAML. And this kind of standard, you know, it will be around 10 years from now, if not longer. And I can guarantee you that you're using it often in some services you're accessing. It doesn't handle mobile well, so it was invented before mobile was even a thing. One of the design decisions was it relies on post callbacks to get the assertion, and that's not really friendly for modern architectures. XML tokens are big, bloated, not very readable, but SAML too is very powerful specification. It has many profiles, many extensions, you can even do SOAP with it, although this comes with a cost, because usually interoperability is a challenge. If a given identity provider is using one of those optional extensions or handling attribute in some special way, you may hit an issue with that. And because of it, it has a pretty high learning curve. Okay, moving on. Then we know the history iPhone happened, and with iPhone, mobile apps happened. But it's not really about mobile apps which changed the whole scenario. It's about those apps being very interconnected. And by interconnected, I mean a scenario like this. So if you're into running, okay, I was running today in the morning, not to brag about it. Then my Garmin watch uploaded my results to Garmin Connect. Then I have a lot of friends on Strava. So I configured Strava, which is another popular portal for runners, to pull this data automatically out of Garmin Connect. And that's what I'm not doing, but I could configure either Garmin Connect or Strava to post to Facebook on my behalf. And you know, I get back from a run, my watch synchronizes with my mobile, and all of the rest happens automatically. I don't really need to do anything. So we have a lot of applications which are authorized to act on our behalf, to access given resources or perform certain actions in our name. And this is called delegation. So that's one thing which really changed the whole scope. And delegation means exactly this. So apps or services acting on behalf of the user. Then apps obviously evolved as well. So when I was starting my IT career in a conference like this talk would be about, you know, proper MVC architecture for a server-side application, and like most of talks would be like that. Modern applications, you know, mobile, client-side, and distributed backend with microservices and cloud, like we all know this, obviously cloud native. So SAML 2 was not enough, and that's the main reason OAuth 2 was born, so for delegation and this kind of access. And here I'm skipping a lot of history, because there was OpenID, there was OAuth version 1, OAuth version 1.2, a lot of custom protocols which different companies tried to push and win the market. But in the end, after several iterations, all the major players like sit together, and OAuth2 was born and kind of like was a winner. OAuth2 is at a very high level similar to what we've seen with SAML. Few things change. So instead of service providers, now we have resource servers, but actually also clients, because those services can access some other microservices and so on. So identity provider is now called authorization server, but in essence, it's still a place where you authenticate, and the place which is issuing a token for you. And then, instead of a browser, it's more complex. And this picture is actually a bit simplified because, stuff from, you have client in both places, right? So it can be kind of like a chain. And then still you have a token which is containing information about you and some attributes, what level of access should you get, and this is passed around. The cool part is that, because it's assigned, any microservice can pass this to other microservice. This microservice will see that it's signed with a public key of the authorization server and is able to make some decisions based on it. So for OAuth2, what you should know is that this specification is actually not that big and not that complicated. In essence, it defines just a few things. It defines how to issue and exchange token depending what kind of application you're using. So it defines 4 flows, one for traditional server-side apps, which is called authorization code flow. Then for client-side apps, we have an implicit flow. We have a direct grant which is resource owner flow for if I want to get a token for myself, and applications, so clients can have this as well. It defines 2 token types, and here is the major kind of like design and principle in this whole specification. So you have access token and you have refresh token. And this is the most critical part about OAuth2. So access token is a short-lived one, like 2 minutes or 5 minutes. And this is the stuff you're passing around to get access, right? So a service will pass access token to some resources and give access on get access on your behalf. Now, access token will be invalid after a short period. So applications will have a refresh token, which has a longer lifespan, like 1 month or 1 year. And then they will use refresh token to ask authorization server for new access token. This gives a lot of flexibility because you can do different scenarios. So if you have a service on the backend which is doing backup, obviously you will issue a very long-lived access token, like an offline token, for it to use. So you don't really need to maintain it. But then, like if you're working in a bank and you want to quickly lay off some people and cut off their access, you can shrink those lifetimes appropriately. And this also gives power to you, because you can go to authorization server and you can see which applications you authorized and cut them off. And in essence, what you will be doing is you will tell authorization server, don't honor those refresh tokens. So you log in with Evernote and gave Evernote access to upload some stuff in a certain place. And then you tell authorization server, when Evernote comes to you with a refresh token, say no. And you cut the integration. And other thing you know from practice, when you log in via Google, via Facebook, those services, there are scopes. So when you authorize certain application, you may allow this application to post to your Facebook wall, or you can just restrict it to only give like a basic profile information. And usually when you're logging with Google or Facebook, you're informed what the application is asking for, and those are OAuth2 scopes. The most interesting part, OAuth2 does not define token format. And funny thing is, actually there are So OAuth2 is not really a protocol in the strict sense. It's more a framework. It's so loose and high level. It's very generic and high level. It lacks the token format. It doesn't cover many useful things. Like, it's not really telling how to obtain user profile. It's not really covering authentication part. It doesn't even specify how clients should be registering with authorization server. So for interoperability, this is kind of a disaster, because if you need to integrate with many of those, you will need to have a custom implementation for any single provider. But that's where other specifications are stepping in, and that's what's forming what I call the OAuth2 ecosystem, and I'll talk briefly about those. Let's start with the token. If OAuth2 is not specifying what is the token format, what is the actual token format being used in practice? And thankfully, industry kind of settled on JSON Web Token. A few years ago, there was still different approaches, but now everyone is using JWTs. And this is because they are simple. So it's a very simple JSON document. You can put whatever you want there and just encode it in base64. And to give you an example how simple it is, so we have a header part and you have a payload part. In payload, you have some attributes which may be handy for your application to make authorization decision. Then you just encode it in base64, and you take header in base64, you slap here, you take payload in base64, you slap it after the dot here, and then you can put a hash, and you have your signature. And if you get this base64 encoded token, you just reverse the process. So it's simple. And that's why everyone is using JWTs right now. And worth knowing that JWT is one of 5 different standards, what's called YOSA. If you need to do any security with JSON objects, don't invent it yourself, because every major language has libraries doing it for you in a secure way. This brings us to OpenID Connect, which in essence is just another spec extending OAuth2. So it's fully compatible with OAuth2, it's just adding things on top or specifying things more. It, for example, adds a new token format. So it's ID token with more user-specific information. And this time, actually, it says, OK, this is JWT token. So there's less room for interpretations. It adds several interesting capabilities. And just to name only a few of those, it specifies how to discover capabilities of an authorization server. There is a whole specification for dynamic client registration. So if you have a single client and you want to integrate it with dozen different identity authorization servers, then there is an automatic way to do it. And vice versa, if you have your authorization server and you need to integrate like 200 clients with it, you can automate the process. The specification, for example, explains how to do single logout from HTML5, so client-side application, which is pretty cool. And a number of things like that. And because of it, OpenID Connect is kind of the new SAML. And by being the new SAML, I mean how widely adopted it is. And because of it, OpenID Connect should be your default choice. It's also for your safety, because everyone is settling on OpenID Connect. So later on, it's fairly easy to swap things out if you stick to the standard. Another interesting spec in our OAuth2 space is user-managed access. So this, again, sits on top of OAuth2 and OpenID Connect. And for the use case, imagine what you do in Google Docs. I think everyone is familiar with Google Docs. So in Google Docs, someone can request access to your documents. You can give access to someone. You can differentiate what level of permissions you give to different people. And then you can revoke their access. So this specification covers exactly this kind of use cases. It defines additional actors, which I will not dive into. It introduces the whole protection API, and obviously there is additional token containing those permission and resource-related information. It's actually pretty cool because users can define application can define resources, and then user can really kind of like see who has access to the resources and really manage it in a centralized way. Other thing I want to mention are financial APIs. So, okay, probably majority of you are not working in a finance sector, but what's happening right now is that financial APIs are greatly impacting the whole OAuth and OpenID Connect space. And I think it's worth understanding what's happening because there may be some iterations about it in a near-time future. So I'll try to focus on this aspect of it. Maybe some of you are aware, but there is something called PSD, Payment Services Directive in European Union. The second version of it applies to any single financial institution operating in Europe. Even if it's a US one, but doing business in Europe, they need to comply. And what it does, it forces them to expose APIs, and it's supposed to boost the fintech industry in Europe. So if any of you want to go into fintech and you have this great idea how to do personal finance application for masses to gather different bank statements and credit card statements and make some advices or, teach people how to save. Thanks to this law, all the banks need to expose their APIs so user can integrate their bank account with your API, with your app via their API in a safe and a secure way. That's the goal. And it introduces a lot of terminology, like those are different actors. I will not go into detail here, but your app would be one of them. The law is pretty high level. I've read the specification, well, I've read the PSD stuff, well, at least briefly, and there is not mention what actually, API is in terms of technical. Like, it certainly doesn't cover, like, that those should be REST endpoints, and it certainly doesn't cover, like, it doesn't say OAuth or OpenID Connect. It's kind of like left for interpretation, how to actually do it. The interesting part from PSD2 is strong customer authentication, which I think is worth bringing up because this term is kind of getting pretty widely used right now. And STA defined what strong authentication is. And strong authentication is considered to have at least 2 of those 3 factors. So something you know, which can be password or a PIN, something you own, so a token or a device, and something you are, so biometric. And to give you the example, if you log into Windows using Windows Hello, so face recognition, and then you authorize your online payment with a PIN, it would satisfy those requirements. And similar, if you're on MacBook and you log in with a password to your machine, and then you use Touch ID to authorize a payment, that's also 2 out of 3, right? So those are secure means of authentication. Now what happened is OpenID Connect organization actually formed a FAPI group, Financial API, and there are specs inside OpenID Connect. Industry formed groups to resolve kind of like the technical aspect of it. There's one in Berlin, which is next gen PSD2, and there is one which I'll mention in UK, which is called Open Banking UK. And this one is very interesting because very shortly they decided, okay, we are going to use OpenID Connect as a foundation of what we will be doing. And they narrowed down some aspects they found lacking in OpenID Connect for financial operations, and they are contributing back. So the result of their work is actually visible in OpenID Connect FAPI specifications. What is really a challenge with financial APIs and OAuth too? It's an interesting one. So if you log into Google or Facebook and authorize this authentication via OAuth to scopes, this is really kind of like coarse-grained. And in finance world, you need to consent and authorize very granular payment operations. So, and in addition, a lot of things are passed in a token or are passed in headers or in the URI itself, and they're, people were concerned that you could tamper some of it, which is not really that much of a problem for typical use case we are doing, but for finance operations, it may be critical. So they kind of narrow down those aspects. Okay, just to summarize this part. For OpenID Connect and OauthN, what you need to know, those are right now a very mature and well-established and supported specifications. So all the major players worked on them. If you access services of any of those players, they do implement OpenID Connect. And most of them are actually, if you're accessing things online via their accounts with those companies, you're doing it with OpenID Connect. So it's a really safe choice and will prove you for the future. There are many interesting and optional RFCs in OauthN specs, actually plenty of them, like crazy stuff. So I'm bringing it up because, if you have any specific needs, you can find a draft or you can find someone working on it. So don't invent stuff yourself, just check there first. And it's evolving space. So homework for you, Google transactional OauthN. There was a pretty recent blog post from a guy involved in IETF who is kind of discussing the financial API problem and how he's listing 4 or 5 different ways to achieve this stuff with what specification provides. There is work on client-initiated back-channel authentication. So essentially, it's not you initiating the authentication. You're informed that someone initiated authentication, and do you agree? Securing JWT secured authorization objects. Or actually, there is a thing in OpenID Connect called request objects, which is not really much used, but this is brought up to fill in gaps for those kind of issues right now. So it's actually pretty interesting space. And yeah, one of guys created this website, and he's already discussing should there be some OAuth next. So it's early days. So I'm not going to frighten you, but right now, this is what everyone is using. It's a very safe choice. Every single product in security space has OpenID Connect integration. But if we meet a few years from now, there may be a new kid in the block. So it's worth keeping an eye. Okay, now I want to talk briefly about passwordless. And this is a pretty hot topic. The interesting part is that, so essentially those 2 specifications. The interesting part is when you Google, you look at YouTube for passwordless demos, usually someone is putting a pin during the demo, which is kind of hilarious, but okay, it's still kind of passwordless. Okay, how does it look from user perspective? So you want to make an online payment, and you initiate the purchase, and then if you're already logged into your operating system, you may, in Windows 10, which supports W3C WebAuthn, what would happen is you're already logged in with Windows Hello, so face recognition, and then Windows will just give you a pop-up, enter your PIN, and you're done. Or, that's when the fun begins. So, fingerprint reader on your laptop, USB token like YubiKey ones, or the other token with some fingerprint scanner, or your mobile app. Cool thing is Android, I don't remember since which version, actually also supports the spec. So Android phone natively via BLE can be authenticator for WebAuthn or face recognition. So okay, I guess you get the picture. There are many choices for how you can authenticate in a very secure way. This is the high-level view. So you have your browser, which supports W3C, and then it implements the API, which you can use as a developer, which essentially is a JavaScript API. And then everything else is kind of transparent to you. You don't really care how it happens. If user registered some authenticators via this API, then verification will just call into those authenticator and you will get the result. You're not even need to be really aware what's there. And then operating system can handle the fingerprint reader on a laptop or face recognition on a laptop and so on. And spec-wise, this is the W3C web authentication part, which explains the web app part. And then the new version of FIDO, so what YubiKey was driving a lot, has what's called CTAP, Client to Authenticator Protocol, which covers how the whole verification, attestation, registration, and everything else should be handled with authenticators themselves. Because there's not so much time, I will not go too much into details here, but just to give you a perspective why it's so cool. So from user perspective, it's great usability. So you can register your authenticator, or you can register many of them. Or you don't even need to implement it yourself. If you're integrated with authorization server via OpenID Connect, and this authorization server is supporting WebAuthn, maybe it will provide it for you. Then user is empowered to manage tokens, so add new ones, or if one was lost, invalidate one, and use several of them depending which one is with him. And have strong security. Why strong? I'll get back to it shortly. Developer perspective, for all of us, it's a lot of convenience. So it's a W3C standard. So there is a standard API supported by all web browsers. Safari is still behind, unfortunately. And Apple, being Apple, is not really saying if and when, but some people claim that seeing some some stuff in issue trackers that they are working, and probably they will catch up eventually. Or actually, you probably should not really implement it yourself because there are a lot of third-party frameworks being developed. It's a pretty hot topic. So I'm from Red Hat. I work on Keycloak, and that's the most demanded feature right now, and we'll support it soon as well. So what you may want to ask is, okay, but how with greater usability and with greater convenience you actually have greater security? Because usually it's the opposite. If something is more convenient and more usable, it's less secure, right? And the answer is PKI. I will not explain what PKI is. I assume everyone working in IT should at least at a high level know what public-private key infrastructure is. And PKI, so private and public keys, were always considered, and the whole CA architecture were always considered like the safest method. And in fact, if you happen to work in the finance industry, you probably have this smart card you need to put to access your machine. Or if you were dealing with government before, you probably needed to have this smart card, which you put in USB device to get access to some systems. And in essence, the smart card has a private key and a certificate, which is on a secure enclave, so you cannot really extract it from there. And this was kind of like a gold standard. If you want to have real security, you should use PKI stuff. The problem was, for a practical day-to-day use, to access website, to do like email and stuff, for normal user, this was never practical. And it never took off. Like there were plans, national IDs will have this and so on, but the key management distribution, this part of it is a hard problem to solve. But luckily, this is essentially what is used in this whole architecture with WebAuthn and FIDO. So FIDO2 authenticators, so the one communicating via the CTAP, they will actually create a dedicated key per application you register this key for, you register this authenticator for. And the cool part is that this makes the website phishing-proof. So if you're familiar with phishing, phishing means you're shown some website which is not actually your website. So it's like a fake bank website. You put your credentials and you're done because someone read your credentials and now they can use it with a real website. And what hackers were usually doing was they tried to fool you with some fancy URL. So they were replacing Western alphabet characters with some Cyrillic stuff or some Asian stuff or some kind of like, Unicode magic. So it looks like URL for your bank, but that's actually not. Now, because the URL is part of the authentication process passed to the authenticator, this will fail. So that's additional benefit. Okay, the other question is, do I need to implement any of this myself? And the other question you may ask, if I'm using OpenID Connect, should I actually implement authorization server? And the answer is no, actually, probably you shouldn't. And for most of you, it's like, please don't. So, implementing any security specification, actually, you may do several things badly. It's a sophisticated knowledge a bit, so the more you can avoid, the better. So here I want to talk a bit about out-of-the-box solution and how it may look for you to integrate with this kind of stuff to get all of those specs for free. And okay, I'm from Red Hat. I have a Keycloak t-shirt, so I'll talk about Keycloak. But to be fair, there are other OpenID Connect providers and other projects solving it. So, a lot of what I will show may apply to different solutions. So Keycloak is something which was from the start designed to make security easier for developers. So, the workflow is you can secure your application with Keycloak with really little to no code. So, for example, if you have a client-side application, you use JavaScript library, you register the client with the authorization server, so Keycloak, then you copy-paste configuration into your client and you're done. And then it provides you a lot of features which otherwise you would need to implement, and they would be costly to maintain and would expose you security-wise. And it leverages one of their standards. Okay. So just 3-minute recap of what Keycloak is. So this should be familiar to you. So it's the same kind of high-level design, and Keycloak speaks both OpenID Connect and SAML2. And actually, you can have many clients talking both of those protocols, and you will have SSO between them. And it also implements UMA and have custom policies you can change, so you can do central authorization this way. And then, if you talk OpenID Connect with Keycloak, transparently you can integrate with LDAP, with Active Directory, and so on. Or you can propagate identity from external providers, like SAML2 or OpenID Connect compliant servers, and do social logging. And then what you also get for free is HA. So this was a demo from Summit last year, where one of the clouds went down and people remained authenticated to the system. Yeah, and it's AIM's mobile app. So I guess this one is clear. So the good part is that, so your application is integrated with Keycloak. And because it's all OpenID Connect, you don't really attach yourself to Keycloak. If you don't like Keycloak at some point, you can easily swap it out with any OpenID Connect implementation. If you go to OpenID Connect website, there is a whole list of different implementations. And then transparently to the application, you can integrate with a lot of existing infrastructure. So different solutions you already have in-house. And as an application developer, you don't really need to care what's behind. That's kind of the promise. You can switch to modern specifications and still exist with the old world. What you get for free is a set of pages, so you can make them look like your application. Actually, Keycloak is very widely used, and I can guarantee you that several times you logged in with Keycloak and you were not aware that this is Keycloak behind. But those login screens you get for free, and you can click enable certain features like registration or remember me, and that's important because you don't want to maintain. So now when we will add web authentication, it will kind of like magically come up for you as an option, or OTP. Then you have set of admin UIs to manage all of it, and user self-service screens where they can, for example, when we implement WebAuthn, they will be able to register their authenticator, and everything is exposed via REST APIs. Okay, just to summarize the Keycloak. So it's SAML to an OpenID Connect. There are easy-to-use integration libraries, so little to no code. You get a lot from centralized session management, so users are able to invalidate their sessions and cut access to some applications, or doing single logout for multiple applications. And you get all of this crazy stuff which normally you need to implement every time for your application, like password policies and this kind of stuff. Yeah, everything is with a UI and everything is REST endpoints, and you have a single place to define tokens and so on. Okay, just to wrap up, but why would you use external solution? So again, I think this is worth repeating, like never try to invent things yourself in identity space. This is asking for trouble. You would want to have less to maintain. Like if you've seen the keynote from day one, less code you write, less bugs you have. Yeah. And right now, the next feature on the list is WebAuthn, so you get this stuff for free. Okay, and I'm done. There are a few minutes left. Any questions?
Okay, so I have a question about the WebAuthn and OpenID Connect, because for me, they are like complementary to each other with an overlapping part on the side of the authorization server. Do you know maybe whether there are plans to I don't know, migrate those two to something like AuthN extension or something like that?
Okay, so the question is about how all OpenID Connect and WebAuthn are overlapping. It's kind of a bit different because WebAuthn is what's happening on a login screen. So if you're implementing a login screen yourself, then you would implement this stuff. And the other part for WebAuthn you need to implement is registration and management of authenticators, right? So if you're doing, security within your application, the login screens and everything else, then you would need to implement it yourself. But if you delegate to the authorization server as part of OpenID Connect, it's all kind of invisible to you because this part of the app will handle it. So I think they are kind of like solving distinct issue, like OpenID Connect is solving how token is being passed, and WebAuthn is more solving solely the whole authentication process. So what happens before JWT token is being issued. Anyone else?
About Keycloak, there is on-premise option and hosted by Red Hat, yes?
So if you go to access.redhat.com, or as a customer, if you go to developers.redhat.com, actually behind it is Keycloak, but there is no like SaaS application being provided which you can buy and use right now. So no, not in this sense. But yeah, but there is also a containerized version. There are images for OpenShift and so on. I'm not so good about blockchain, so I think I'll dodge the question a bit. Okay, you mean like using blockchain for authorization? I think it all depends on the use case. So centralized authorization is kind of like people always try to avoid those calls to centralized place. and then they develop some custom thing which is supposed to be faster, and then they end up with even worse solution. It's really a nuanced thing. So designing a proper authorization solution is really kind of like very specific to your needs. So I don't think there is like a universal answer about blockchain would be better for you know, in general. I think it's all use case based. I think I'm not really answering your question, but yeah, that's what I can say.
Is it possible to enforce an authorization policy that requires a particular type of factor to be used on the final side? Like, I want to use biometric, I don't want to allow the use of facial. Or are those two trust domains completely separated?
I'm not sure if it's covered by the spec itself, and I think not, but typically what you would get with authorization servers is, and we actually lack this in Keycloak, being honest, is a step-up authentication. So then your client can receive information what type of authentication user used, and you on application side can actually differentiate. So this authentication was strong enough for this kind of operation, but now if you want to like do the payment, please, you know, step up with your authentication, and you would need to provide additional stuff, right? Like, for example, if you're using Allegro, you can browse and you can, like, if you want to edit your profile, you're actually asked to authenticate once more, right? So this is actually a great example of step-up authentication. Certain operations are protected in a great way. And again, I don't think this is covered by specifications itself, but typically authorization server will inform you and will provide you such capability.
One more, because when you rely on a Keycloak, for example, on any server which provides the data, it is one point of failure as well. So is there any protocol or any way to handle such a failure of authentication provider?
But so I showed so we have clustering, right? And then we have multi-data centers. So usually you just do clustering within data center and then many data centers. So even if one data center dies, load balancer will switch you. So then it's not a failure of identity provider, it's a failure of load balancer you're worried. Does it answer your question?
Mm-hmm. The servers, it is about failing the authentication provider itself, and how the system will behave
But is your concern that some of those external integrated with Keycloak will fail? Then you, like when you integrate external authentication, usually, actually right now, what will happen is that Keycloak user will also be created. So we can still authenticate via Keycloak itself with a login password instead of this external one. So it's not like you only rely on this, and actually you can have many of those integrated. So you can integrate few different social login providers with your Keycloak account, and then, you know, if one of them dies, it's not a problem. Okay. All right, time is up. I'm here towards the end of the conference. I'm leaving Thursday, so if you want to catch me, I will be available. Thank you.